Okay, so let's review before we go a bit deeper into the periodic table. First, let's remember that an atom is made of three subatomic particles: protons, which have a positive electrical charge and a mass of 1 AMU. Neutrons, which have a neutral charge and also have a mass of 1 AMU. So the protons and the neutrons in the nucleus of the atom make up the mass of the atom. And since we have positives to balance that out on the periodic table, we have the negative electrons, which are found in the electron cloud. And electrons travel in energy levels around the nucleus. Remember that the outside energy level holds the valence electrons, which we'll talk a little bit more about later. But 2 electrons will fit in the first energy level. Up to 8 electrons will fit in the second energy level. And those are valence electrons. And in the third energy level, up to 18 electrons will fit, but only 8 of those are valence electrons. Remember that when we're looking at the periodic table at an individual element, the atomic number gives us the number of protons, but is also the same as the number of electrons. Of course, we have the symbol for the element, which always starts with a capital. If it's 2 letters, the second letter is always lowercase. And then we have the atomic mass. Remember, to get the number of neutrons, we round the atomic mass to the nearest whole number. We subtract the atomic number, and that will give us the number of neutrons for the element. Alright, let's remember that valence electrons are the electrons on the outermost energy level. These are the electrons that get shared or lost or gained in order for bonding to take place between atoms of elements. To determine the number of valence electrons for groups 1, 2, and then 13 through 18, remember that we look at the group number. In group 1, they all have 1 valence electron. In group 2, each element in that group has 2 valence electrons. In group 13, they have 3 valence electrons. We just dropped the 1. In group 14, they have 4. In group 15, 5. In group 16, they have 6 valence electrons. Group 17, they have 7 valence electrons. And in group 18, they have 8 valence electrons. We can also determine the number of energy levels in an atom by looking at the periods. In period 1, we have one that has 1 energy level. Those are 2 elements in period 1. Period 2 has 2 energy levels. In period 3 has 3 energy levels. Period 4 has 4 energy levels. Period 5 has 5 energy levels. Period 6 has 6 energy levels. And period 7 has 7 energy levels in the electron cloud. The periodic table has 3 major groups or categories of elements. The first group or category of elements are the metals. The metals, I'm going to outline here, take up most of the periodic table. The metals are found on the left side of the periodic table, and they go over almost to the stair step including aluminum there. Come back around. Notice that hydrogen is not in that group. Hydrogen is a gas and it's a non-metal. So all of these elements are metals. And then they also include, down at the bottom, the lanthanide and the actinide series. So all of those are metals. The next group on the periodic table that we'll talk about are the nonmetals. The nonmetals are found all the way to the right on the periodic table. Again, they are to the right of the stair step, but not including those elements that are connected to the stair step. So I'm outlining them in green, and these are, the nonmetals. And finally, right between the metals and the nonmetals, along the stair step, everything connected to the stair step on both sides, with the exception of aluminum, are metalloids. And so these are the metalloids. And finally today, let's talk about the groups on the periodic table. Groups on the periodic table are also known as families. They're known as families because the elements that are located in an individual group, like group 1 or group 2, have very similar properties. Whereas if we go across the periodic table from left to right, the properties change slowly as we go from group to group. All right. The groups on the periodic table are named, and you must know these names. Group 1 on the periodic table, which does not include hydrogen, because hydrogen is a gas. Group 1 on the periodic table are the alkali metals. The alkali metals. Group 2 on the periodic table are the alkaline earth metals. Group 3 on the periodic table consists of all these elements in between, groups 3 through 12. And groups 3 through 12 are known as the transition metals. All right. Down at the bottom of the periodic table, the lanthanide and the actinide series are known as the rare earth elements. So these down at the bottom are the rare earth elements. These are elements that, for the most part, are synthetic. They're not found in nature, but are man-made. Though that's not true of all of them. Some of them are found in nature, such as uranium. Down here at the bottom, uranium is a natural element, where plutonium is made in nuclear reactions. All right. Moving on across the periodic table, we have a small group of metals down here. They are very soft metals, and they include aluminum and tin, and they go up here. They're right next to the metalloids. And this group of metals are known as the other metals. We move all the way over to group 17. Group 17 are the halogens. Halogens are a group of elements that are generally used in different types of cleaning materials, such as bleach, toothpaste, or even medical uses like iodine. And then our last group, group 18, are the noble gases. The noble gases, remember the noble gases have 8 valence electrons with one exception, helium. It has 2 valence electrons, but their outer shell is full, so they do not bond with other elements, and they're found alone in nature. Backing up just a little bit, remember the alkali metals? The alkali metals have one valence electron. They are extremely reactive. They will not be found alone in nature. Group 2 have two valence electrons. They're pretty reactive as well and generally won't be found alone in nature. The halogens are the same way. They have 7 valence electrons, so they're missing one, and they too are very reactive. They are the most reactive of the nonmetals. And so that's our lesson today over the periodic table.